Good morning, students. Come back to the next series of solutions questions. The water factor for 0.1 barium nitrate, BaNO3 twice, barium valency is 2 and nitrate valency is 1. So BaNO3 twice. Solution is 2.74. The degree of dissociation is, they're all given in the percentage. You just see the strict formula. Degree of dissociation is nothing but alpha. If it is for association, degree of association and dissociation. In case of association, alpha is equal to water factor I minus 1 divided by 1 minus n into n. And the degree of dissociation, alpha is equal to I minus 1 divided by n minus 1. N is number of ions. Here, I is equal to, water factor is equal to 2.74 for barium nitrate. So barium 1, nitrate 2, totally 1 plus 2, 3 ions. So N is equal to 3. Substitute this is for a dissociation. The formula is alpha is equal to I minus 1 divided by N minus 1. For association, it should be the formula is invert. I minus 1 divided by 1 minus N into N. For dissociation, alpha is equal to I minus 1 divided by N minus 1. So alpha is equal to I minus 1 divided by N minus 1. I value 2.74 minus 1 divided by number of ion is 3, 3 minus 1. So 1.74 by 2 is equal to 0.87. In order to get a percentage, multiply 100, 87%. During depression of freezing point in solution of the following in equilibrium, liquid solvent and solid solvent, liquid solvent and solid solute, liquid solute and solid solute, liquid solute and a solid solvent. Here the example is liquid solvent is nothing but water. On cooling the water, we will get a ice of ice. So ice cubes is nothing but solid, H2. Liquid to solid solvent. Both are solvent. One is liquid solvent on cooling. Water solvent is the correct answer at a equilibrium. If you melt this water, you will get a liquid water. So that is called equilibrium, both forward and backward reaction. In 1996, the question number 22, the molecular weight of benzoic acid in benzene as determined by depression in freezing point method corresponds to ionization of benzoic acid, dimerization of benzoic acid, trimerization of benzoic acid, solvation of benzoic acid. Benzoic acid formula is C6H5C/H. Structural formula C6H5C double bond O and a OH. So it is a dimerization. So it forms C6H5C double bond O and O, another benzoic acid linked with the hydrogen. This is a hydrogen bond formation. It is called dimer of benzoic acid. So the answer is dimer of benzoic acid. Whenever you see the benzoic acid, you write a dimerization. Freezing point of equimolar aqueous solution will be the highest. This is for anilinium chloride, C6H5NH3Cl. NH3Cl is called anilinium. C6H5NH2 is called aniline. HCl we had it is called anilinium chloride and calcium nitrate and cerium nitrate and glucose. So delta TF is equal to I into Kf into M, cryoscopic constant. Delta TF is equal to I. I is equal to N, number of ions. So delta TF is directly proportional to number of ions. So delta TF increases, number of ions also would be increases. So already I said if the number of ions decreases, delta TF decreases, but freezing point of solution increases, just opposite. So here number of ions increases, freezing point of depression also increases, but freezing point of solution decreases. Here just to see number of ions here anilinium C6H5NH3 plus Cl minus. So it is totally 2. Here calcium nitrate, calcium 1 and nitrate 2. So 3 ions. And cerium nitrate 3 plus 1, 4 ions. And glucose is the non-electrolyte. It is only 1. So here the question is only 1. If it is a number of moles decreases, here all increases, here 2 and 3 and 4, here only 1. So only is the least value is last option. So number of moles decreases, number of ions decreases, the delta TF also decreases, but TF would be increases. We are asking highest freezing point of the solution increases for a very least number of ions of non-electrolyte of glucose. This is a trick formula to understand this relation between depression in the freezing point and the number of moles together and a freezing point of solution. Opposite answer. And if molality of the dilute solution is doubled, the value of molar depression constant, or Kb will be unchanged, doubled, halved means half, tripled 3 times. So Kf, molar depression constant, only depends upon the nature of the solvent. It is independent of the concentration of the solution. So it is unchanged. Please by heart this note bin. The water factor I for a dilute solutions of a strong electrolyte of barium hydroxide, barium BaOH twice. Barium is 1 and hydroxide 2. Barium valency is 2. So what 2 barium on hydroxide is nothing but 3. So 3 is the water factor I is equal to. For strong electrolyte, I already told you I is equal to N. Number of ions is equal to water factor. So let us see the number of ions of barium hydroxide. Water factor I is equal to total number of ions present in the solution. Barium hydroxide is a formula BaOH twice, Ba2 plus 2 OH minus 1 plus 2 is equal to 3. Thanks for watching, students.